Which brand of car has the highest sale price? How does the number of miles driven impact the sale price? And why did one car sell for 16 times more than the average of that model? We can find the answers to all of these questions and more with the power of SQL and a car sales dataset. In this video, we'll download the dataset, import it into an SQL database, and run some queries on it to learn more about the data. We're going to use this dataset here called vehicle sales data on the kaggle.com website. You can find a link to this dataset in the description. To download it, click on the big download button on the page here. You'll need to be signed in to the Kaggle website first, so create an account and sign in if you haven't already. Save the file somewhere on your computer. It's about 20 megabytes, so it should be pretty quick. This is a zip file, so we'll have to extract it before we can import it. So extract it on your computer. We now have our CSV file here, called car prices. Let's import it. For this video, we'll use a MySQL database and the MySQL Workbench tool. You can use whatever database you like. We're going to import the CSV file into our database. I've got videos on how to do this in other editors and databases, which I've linked in the description. First, we'll create a new database. Click on the new database icon on the toolbar. Give it a name, such as car sales, and click Apply. On the pop-up that appears, click Apply again. Click Close on the confirmation window, then close the tab here. A new database will be created. Double-click on it to set it as the default and the name will be bolded. Now we can import the CSV file. Right-click on the car sales database and select Table Data Import Wizard. You'll see the Table Data Import Wizard. Click Browse and locate the CSV file that you extracted earlier. Click Next. You'll see the destination screen. You can either select an existing table to import the data into or create a new table. Creating a new table is selected by default, and the name is set to your file name. You can change this to whatever you want the table to be called, but for us, we can leave it as the default. There's a checkbox you can select called Drop Table if exists if you want to drop the table before creating it. This is helpful if you are importing the CSV file again and want to create the table from scratch. Click Next once you've changed any of these settings. For this example, we'll leave it as creating a new table with the name unchanged. You'll then see the Configure Import Settings page. You can see the encoding, which in most cases you can leave as the default value. If you get errors during the import process, you may need to change this value and try again. The columns from the CSV file are shown. Each of them has a checkbox to the left indicating whether or not you want to import that column into the table. You can also see and change the data types for each column. These are determined from the data in the column, but if it's not right, you can change it. This is another area that can cause issues when importing, if the data is too large for the column. These are the values I've used, so you can change them to match. You can see a preview of the data at the bottom of the window. You can click on the wrench icon to change some more settings, such as line separator, enclose strings in, field separator, null and null as SQL keyword. Click Next once you've made any changes. You'll then see the Import Data screen, which is essentially a confirmation screen. Click Next. The two steps shown will then be performed, and hopefully green ticks will appear next to them, indicating it was successful. Click Next to continue. A summary page is shown, letting you know how many rows were imported. It should say 558,837. Click Finish. The wizard is then closed. The data should now be imported. If you get any errors with this process, you could try change some of the settings that we looked at earlier or Google for the error message. You could also read the comments on this video to see if anyone else has the same issue and has a solution. Alright, our data is now imported. Let's run some simple queries on it to see what it looks like. We'll start with a simple select star. We can run this and see the results in a few seconds. It took a few seconds because there are almost 600,000 rows in the table. We can see some details about the car, such as the year, make, model, trim, body and transmission. We see the VIN, which stands for Vehicle Identification Number and is a unique number for a specific vehicle. The state is the state in the US that the car was registered in. The condition is a number from 0 to 50 to rate how good or bad the condition of the car is. This information is explained on the Kaggle dataset page. The odometer is the distance the car has been driven, which I assume is in miles because it's data from the USA. We have the colour of the car and the colour of the interior. We have the seller, which I think is the dealership or maybe the person who sold the car. The MMR is the Mannheim Market Report, which I think is some kind of estimate of the car's value. The selling price is the price that the car is sold for. And finally, the sale date is the date and time the sale was done. There are a lot of interesting things we can try to discover in this dataset. Let's start with some simple queries and move on to some more complex queries. One of the fields was the state. One question we could ask is, how many cars were sold in each state based on the state of registration? We can write a query to show the state and the count of values for the state. We can run this and see the result. We see a value of CA here, which is California, then TX, which is Texas. At some point, we could translate these into more readable names, but we'll keep looking at the data for now. We can keep scrolling down. What is this here? We see some values that don't look like states at all. These are long alphanumeric values that look similar to each other. They each have a count of 1. What's happening here? There could be a problem with our query, but it's a simple select and group by, so it's unlikely. There could be a problem with the data. Perhaps the source data is incorrect. Perhaps the data was not imported correctly. What can we do? First, let's find out a bit more about these values. We have one of these state values here. Let's see what the rest of the row looks like. We'll select all columns from this table where the state equals this value. We can see the results here. The year is 2015, the make is Volkswagen. The values look okay so far. We can keep going across and do a mental check to see if the values make sense for each column. We can see a body value here of navigation. That doesn't seem like a type of body value. I would expect things like sedan or SUV. The transmission value is sedan, which doesn't seem right either. The VIN is automatic, and the state is that strange value we saw. So I think what has happened here is that the import process has not worked correctly for this row, and the others that had those strange state values. It has pushed the navigation value into the body column, as it thinks it was a new column. It could have been because there was a comma between the connectivity and navigation. Let's see what the other rows look like that have those odd state values. We can go back to the results of our earlier query. We want to use these odd values into our query so we can use them in the where clause. Rather than copy and paste them, let's try a different approach. We'll change our earlier query to look for values where the length of the state value is more than 2. We saw that the valid-looking state values were 2 characters and the others were longer. In MySQL, we can use the length function for this. So we can run this query and see the results here. Interesting. It looks like every row is for the same type of car, a 2015 Volkswagen Jetta with this navigation item. How can we fix this? Let's look at the source data. I've opened the CSV file here. I'd like to see what the row looks like in this file. Perhaps it has an extra comma or some quotes or something. Fortunately, we can search for a value that is common with all of these rows, which is navigation. Notice how it's not spelled correctly. We can see one row here. The previous value has this SEPZEV with connectivity value, then a comma, then navigation. This is an issue because it seems like the navigation is meant to be part of this previous field, but it has a comma. We could do a find and replace on this file to remove this comma in between and re-import the data. But before we do that, let's check the rest of the data. We can see on the far right there is no sale date for this record. Sometimes these kinds of records, where there is an extra comma, will contain all of the data, but in this case it doesn't. So even if we fix the data and import it, we don't have any sale dates, so it's an incomplete record. What do we do to exclude this data? There are a few things we can do. We could delete it from the table, which would be the easiest. We could create a view that excludes this data and then select from the view. However, I'd like to try a different approach, only to demonstrate how it can be done. We'll create a temporary table to store the valid data, excluding this data. I'll do this because sometimes we don't have permission to create new tables or views, but temp tables are usually okay. First, we'll write a select query to find the invalid data. The current query uses the length function on the state value. Perhaps we can use something simpler, such as where the body value equals this navigation value. Let's select this data. We can see 26 records just like earlier. We can also see the same issues with the data, so this query would work for us. Let's create a temporary table. To do this in MySQL, we can create a new table and use the word temporary. Instead of specifying the columns and data types, we'll write a select query. This select query will get the data where the body value is not equal to navigation. Our query looks like this. We can run this query. After a couple of seconds, the table is created. Alright, from now on, we can work from this car prices valid table. If we have any other data issues, we can update our temporary table. Let's run that earlier query about the states, but run it on the new temporary table. We can see the results here. It looks much cleaner, with only valid states in the list. This gives us an idea of the numbers of sales for each state. So that's a good example of using a temporary table to find and exclude data from our analysis. If you want to get all of the SQL queries mentioned in this video, including the select queries and all of the data updates, get your free guide to this project by checking out the link in the description. Let's look at another question. We want to see which kind of cars are most popular. How many sales have been made for each make and model? We can write a select query to show the make and the model, and the count function. We'll group by these columns. Also, let's sort by the count value in descending order to see the most popular ones at the top. We can see our results here. The most commonly sold car is the Nissan Altima. This is interesting and it answers our questions. A little further down we can see some blank rows. We have an empty make and model and there are about 10,000 records for them. This doesn't look right. Let's explore a little further. Looking for values like this can be a little tricky, so let's see if we can find them. The values are not null because they would have been shown as the word null. Perhaps they are an empty string or a space. Let's try an empty string. We can select from our table and find all rows where the make is an empty string. We can see our data here. Most of the columns look okay, but the make, model, trim and body are all empty. Let's say we want to exclude these rows from our analysis. To do this, we can update our temporary table. First, we'll drop the temp table. Then we update our select query for creating the temp table to only include rows where the make is not an empty string. Now let's run that earlier query again. We can see the makes and models here, with the number of sales, and the rows with the missing make and model are not shown. So that question is now answered. Let's see what we can learn about the sale prices. Are there differences in sale prices for each state? What's the average sale price for cars in each state? We can find this in a similar way to other queries. We can select the state value and the average of the selling price column. We'll order this by the average price in ascending order this time. We can run this and see our results. It looks like the state with the lowest average price is NM, and the highest average price is from ON. So this question is answered. We didn't find any data issues with this. Let's look a little further into sales. Let's say we wanted to find out the sale prices for cars over time. What is the average sale price for cars sold in each month and year? To do this, we need to find out the month and year from the record of when the car was sold, and then get the average selling price for each month. Let's look at our data again. We can see our data here. We can scroll to the right to see the sale date column. It has a pretty helpful value for the date, the day name, month, day, year, time, and the time zone. Before working on this field, it's helpful to know what the data type is. To find out, I'll expand the car prices table on the right. We are looking at the car prices valid table, but this was created from the car price table, so it's a good start. Click on columns and we can see the details in this panel here. We can scroll down and it says sale date text. That's not good. It means the date value is stored exactly as we can see it, and we can't easily perform functions on it to get the date components. We'll have to translate this to a date value and then work on it. Let's do that now. The first step is to convert this sale date text value into a date data type. We'll select just the sale date so we can focus on that. And because we'll be running queries like this a lot, We'll limit the data to a small number of rows so it runs faster. Let's start by extracting the year. We can use some string manipulation functions to get the year number from this. We can either look for it based on the position in the string or based on other delimiters like spaces. It looks like the values that come before it are all the same width. 3 characters for the day, 3 for the month, 2 for the day number. So this is helpful. We can use the mid function to extract the value. The first parameter is the value to read, which is sale date. The second parameter is the number of characters to start from. In our field, we have 3 for the day name, 3 for the month, 2 for the day number, and then 3 spaces in between. This is a total of 11, and the first character is 1, so we can specify the number 12. Hopefully this will show us the right value. The final parameter is the length of the string to return. We only want 4 characters, so let's enter 4. We can give this an alias of sale year. Now let's run the query. We can see a column here called sale year, which shows the right year. That's great. If the value looked a little off, like it didn't have the right year, then we could adjust the mid function. What about the month? We can do the same thing by using the mid function to get the month name. This time we use the starting position of 5, because we start at 1 and then there is 3 characters for the day name and 1 for the space. We only need 3 characters as well. We run this and see the month name here. So far so good. We have a similar mid function for the day number. We can run this and see the results here, which shows the correct day. There's one more thing we can do here. We've got the name of the month, but if we want to sort our data by the order that month comes in, we need to get the number of the month. If we sort it as it is, we'll have values like April and August at the top, instead of January. So we'll need to convert these month names into numbers. One way to do this is with a case statement. We could use a lookup table, but we'll assume we can't create this table, so we'll just update our query. We use this case statement here. We can run the query and see our results. We can see all of the components of the date. So far so good. We've got the code here to extract this date information from the text field. What if we need to use this information in several queries? It would be a hassle to copy and paste this code all the time. What we can do is add these columns to the temp table. We can calculate these values once, store them in the temp table, and then use them every time. Let's do that now. First, we drop the temp table. Then we'll create the temporary table again, except we'll add our new columns to it, the ones that use the mid function and the case statements. Because we're adding extra columns, now might be a good time to use all of the column names in the select query instead of select star. Also, when we use the column names of year and condition, we can see they appear in blue. This is because they are reserved words in MySQL. We can add backticks around the column names to treat them as names and not keywords. However, it would be better if we didn't have to do this every time. We can improve our temporary table and queries by adding a column alias to these. We'll call the year column manufactured year and the condition column car condition. We can run this and the table is created. Let's run a simple select star to see the data. We can see all of our columns here, including the new names for the year and condition columns. We can scroll to the right and see the new date columns. This looks good. Now we can easily write a query to get the average sale price for each month. We can select the sale year, sale month, and the average of the selling price. We'll group by these columns and order by these columns. We can run the query and see the results. We see the average of sales for each year and month. This question is now answered. Now that we know a bit about the dates of sales, what if we wanted to know which month of the year had the most sales? We want to find the most popular months regardless of which year they are in. This is simple now that we have extracted the date components. We can select the month numbers and count of sales. We can run our query and see the results here. We can see that the month with the most number of sales is month 2, which is February. You may have noticed that the month number 12 is sitting after 1 and before 2. This has happened because the value is stored as a text value and not as an integer. We can update our temporary table to resolve this. First, we drop the temp table. Then we create the temp table in the same way, except we surround our case statement with a cast function. We can use this to convert the data type to an integer. In MySQL, we can't convert to an int, but we can convert to either a signed integer or an unsigned integer. A signed integer means that it contains either positive or negative values. We don't need that, so we will use unsigned. We'll also need to change this final value to something else, because none is a text value. Let's use the value of null. Run this statement and the table is created. We can now run our earlier select query to see months and see the order is better. While we're here, we have 12 sales that are missing a month. Let's look into this to find out why. Perhaps they are missing date values or our mid function didn't work correctly. The month number is translated from the month name. So what does the month name look like? We can run this select query to find the count of different occurrences of the month name. We can see the results show 12 values with a month name of an empty string. Let's find the details of these 12 rows. We can do that by filtering on rows that have an empty string for the month name. It looks like there are a range of sales that have no sale price and no sale date. The missing sale date explains why there is data missing for the month name. Do we get the same results if we check for a sale date of an empty string? Yes, it looks like we do. So we should update our temp table to exclude these records. We can drop the temp table and then add a condition to the select query to only find records where the sale date is not an empty string. We run this and the table is created. We can go back and run our earlier query to show the months, and we can see the same data, but no records for the missing month names. This is what we want. So that question is answered. The queries we've written so far have been fairly straightforward. Let's get into some more complex queries. Our sales data has information about different body types, such as sedan and SUV. We'd like to know what are the top 5 most selling models within each body type. So we want to see the make, model, body and number of sales, but only show the top 5 for each body type. Sounds complex. How do we do this? First, we'll need to find the make, model, body type and the count of sales. This could be done with a group by query. Let's try that now. We can see our results here. It shows what we expect: make, model, body and a count of records. But it's not in any order. Let's order the data. We want to order the rows by the body type and then the number of sales. Our results are now sorted. We've got some rows here with an empty body, and if we keep scrolling down, we see other values like convertible. So we can see in this list the top 5 for each body type, but it shows everything and we only want the top 5. How do we do this? We need to calculate which of these records are in the top 5, and then filter all others out. To determine if a row is in the top 5, we need to calculate its position or ranking when the data is ordered. There's a function called rank which we can use for this. Let's add rank to the query. We need to add the rank function and then the over keyword. This will run this rank function as a window function, meaning we will calculate a value for each row, but it will look up other rows. We write over, and then inside the brackets we specify how the rank is determined. We want to rank on the highest to lowest count values, so we write order by count desk. We can run this and see our results here. Each row has a rank value. We can scroll through the results and see how the value changes. The rank value is quite high. This is actually because the rank is calculated for all records. If we sort by the count value in descending order in our results, we can see that the rank values start at 1 and go up from there. However, we don't want the overall rank, we want the rank within each type of body. We can do that with another keyword called partition. Inside the over brackets, we add the word partition by, and then we specify the column that we want the rank to be calculated within. For us, we'll specify body. We'll also give it a column alias to make it neater. We can run this query and see the results. Now we have a rank value starting at 1 here and working down. When we get to the next body value, the rank resets. This is what we want. Now we can filter our results to only show records in the top 5 of each body, which is where this body rank is less than or equal to 5. We could write a where clause or a having clause to filter this out, but an easy way is to surround this query in another select query and filter on it. This means we can simply refer to the body rank column we have calculated. We'll give the count column an alias so we can select it, and move the order by to the outer query. We can see the results here. It only shows the records that are in the top 5 of each body. This is the result that we wanted. We've used the subquery and the rank function as a window function to get what we needed. If you want to get all of the SQL queries mentioned in this video, including the select queries and all of the data updates, get your free guide to this project by checking out the link in the description. Let's say we're looking at the sales and we want to look for outliers. We want to find any sales where the sale price is higher than the average for that model, and how much higher it is than the average. We'll start by getting the make, model, VIN, and some of the date components and the selling price of each record. We can see some information here. We need to calculate the average for each model. How can we do this while also showing the details? Anytime we need to use an aggregate function like average and also see the details, we can use a window function. So let's calculate the average. We add this column to the select clause. We find the average of the selling price. Then we add the over keyword. Inside over, we add partition by because we want to calculate the average for a subgroup of data. We want the average to be for the combination of each make and model, so we add that inside the brackets. We'll call this column average model. Now we run the query. We can see our results here. The rows are shown by the make and model, and we can see that all of these rows with the same make and model have the same average value. We can scroll down and see more models, which have a different average. So we can see the average for each make and model. The question we want to answer is about sales higher than the average and how much higher. Just like the last question, I find it easier to filter on results of functions like this by surrounding this query in another query. So let's do that now. We select all of the columns, including average model. We add a where clause to filter on rows where the sale price is higher than the average. We run this and see the results. All of the rows are higher than the average for that model. Finally, we need to see how much higher they are than the average. We could either do a subtraction to find the absolute number or a ratio which uses division. Let's find the ratio so we can see if a price is 1.5 times or 2 times the average, for example. To do this, we add the calculation to the select clause and give it an alias. Let's also sort by this column so we can see the biggest outliers at the top. We can see our results here. They are ordered by this price ratio, and the top result is this Ford Escape which sold for $230,000, which was about 16 times the average price of $13,000. That's a big difference. So that answers our question on sales that are higher than the average. We saw in our sales data a column called condition, which we have renamed to car condition. How does this condition value impact the sale price and how many are sold? Let's find out. We can write a simple select query to find the condition values, the number of sales and the average sale price. We can see all of the condition values here, the number of sales and the average sale price. This is a little interesting, but it's a little too detailed. Let's say we wanted to see if generally lower condition cars are sold at the same price or a lower price compared to the medium or higher condition. Rather than show each individual condition value, we can group them together. It looks like we have values ranging from 0 all the way to 49. What if we group them into buckets of 10s? So all conditions from 0 to 9 in one bucket, and 10 to 19 in the next bucket, and so on. How can we do this? We can use a case statement to specify groups. We check the car condition column and use between to group the rows into different values. We can then update the group by and order by to refer to the result of the case. We run this query and see our results. The condition has been grouped into 5 different buckets and we can see the number of sales and the average price. It looks like the average price increases from the group of 10 to 9 up to 40 to 49, but the 0 to 9 group is in the middle. To find out more, we could go back to the detailed view of each condition or look into other attributes of the data. Perhaps there are certain models that are low condition but are popular or some other reason. But for now, we've answered our question. How does the odometer value impact the selling price? Let's see. We can find the odometer value, number of sales, and the average selling price in a similar way to the last lesson. We run this query and see the results. There are a lot of rows here. Like the last lesson, the results are a little too detailed to get insight from. Let's group them into buckets. It looks like the highest value is just under 1 million. Let's group it into buckets of 100,000 each. We can do this using a case statement again. The case statement will find the first condition that is true and return that value, so we can use less than instead of between to make it simpler. We can run this query and see the results. The results show the groups of odometer values into 100,000 value buckets. We can see there are a lot of sales for cars in the first group, and the average sale price is the highest. It goes down as the odometer goes up. So that's interesting. It's a handy way to analyse data. Let's say we wanted to create a report on the different car brands or car makes. For each make, we want to see the number of unique models that have been sold. We want to see the number of sales, the highest price, and the lowest price. Let's start writing a query. We can select the make, then the count of model, then the count of all records, and then the min and max of the selling price. We run this and see the results. It looks interesting. We can see each make, the min and max price, and the number of sales. However, the num models column shows the same value as the number of sales. That doesn't seem right. It also doesn't seem right that Kia has 18,000 unique models. Well, this has happened because we have counted the model column, which actually counts the number of non-null values. If there are 2 values of Sorrento, it counts a value of 2 and not 1. How can we get the unique model values? We add the word distinct inside the count function. We do this and see different numbers. The number of models is much smaller and seems more realistic. This is interesting and answers our question. But what if, after we saw this, we wanted to see which brands had the highest average price and then sort by that average? We could add an average column to our query and then add that to the order by. We can run this and see our results here. We see the top brands by the average price are Rolls-Royce, then Ferrari, then Lamborghini. We've got a lot of cars sold in our database here. Over 500,000 records actually. Are there any cars that have been sold more than once? And what are the details of those sales? In order to find this, we need to find a way to uniquely identify a car. Fortunately, we have this in our table. It's the VIN field. Let's select all of the columns from our table to start with. We can see all of the columns here. Now we only want to show records where the car has been sold more than once. To do this, we need to calculate the number of sales for each car. And to do this, we use the count function and base it on the VIN column. We want to show details of the rows and also run this aggregate count function. To do this, we use count as a window function. We can add count to the select query and use over with partition by the VIN. We run this and see the same data, but a new column called VIN sales. Now we have this value, let's filter our results to only show rows where this VIN sales is greater than 1. We'll try this with a where clause this time instead of surrounding it as a subquery. We try this, but we get an error about an unknown column. What if we change this to a window function instead? We run this and get a different error. So it looks like we can't filter on this column. We can do this by surrounding this in a subquery. We can see our results here. All records have a VIN sale of more than 1. We can see the details of each sale. The first 2 rows here are for the same car. We can see there are a couple of changes between rows. The odometer is slightly higher and the selling price is slightly lower. The selling date is roughly 1 month later. We can see similar rows for more cars. There are 16,000 rows returned, so there are many cars that have been sold more than once. With this data set, we could analyse it further to find the average time between resales, changes in sale price, and most common models. Once again, if you want to get all of the SQL queries mentioned in this video, including the select queries and all of the data updates, get your free guide to this project by checking out the link in the description. If you enjoyed this video, you'll want to watch my other data analysis project video here, which is about how populations of countries change over time and what we can understand from that data. Thanks for watching.